Previously, I have been showing you how to do the column design. In this session, we'll continue to show you how to do the wall design. So let me open one ETABS model. So I have a simple model here. But before going to show the wall design, I want to recapture the way we do the load combination. Let's see, we have this empty the empty model. We don't have any load case yet. Um, so from the programs, you can do very fast. You can be very fast of your load case by here I create one template already, but this template is very simple. You can do the same thing by just create the list of load pattern and create the a table. You can tabulate a table of load case like this. It's quite easy. And then also tabulate the envelope. Sorry. So once you have this type table, you can use the program to build your load pattern very fast. So let me show you. So in order to build the load pattern, you go to this output button from the menu. And okay, sorry, first you need to make sure that the ETAP window need to be active for API. You click here. Then you go to the output. Sorry, you turn on the output and you select now you have the list of the load pattern. One is the name of the load, and the second column showing the type of the load. So if you want to have the load pattern with different type of load pattern, you can go back to the define and go down all the way to the list here. I list some of the key the key in index for the load button. If you want to change the load type, you basically you just need to double click here so that it will write the type of load. So since you, for let's just example, you already have these two columns, you go back to the output and now you just click uh, update a load pattern and you go back to the program and you're going to define. You can see the load pattern has been imported to the program. Here because previously it has the dead load already, but now I create the different name for the dead load. So I'm going to delete this dead load, but be very careful that now you have a new load pattern for the dead load. You need to set this weight multiplier to 1 and then click modify. Be very careful. Otherwise, it will not count. It will not automatically count your cell weight. Now you can further do some modification of some of the notational load or wind load. So wind load, you also have to set back to the wind that you want to calculate, because the program just gives you the list of load pattern only. So the more details of the load you have to modify a little bit. Okay, assume so now the load pattern has been imported. Next, you continue with the table of load combination. So you have this table with all the load com name and this row showing all the list of the load case. Then you select all the table, cover the selection shall cover all the load case that you want to create. I was just select here only because these load don't have any coefficient. So I will click update combo, and the program will update the combo for you. Yeah, well, all of the combo will be updated. Okay. Uh, after you finish that step, you need to double check whether the combo has been input into your program correctly by click view combo. So it will replot the combo list and the road case and the coefficient for you again. So now you already make sure that the program is the combo is input correctly, so you delete this. Next, you will continue with defining the load envelope. So the envelope will start with the name of the envelope that you want to do here, and continue with the list of all the load combination. And the next column is the coefficient corresponding to that combination. If you want to do more envelope, you just need to create one more two more column like this. You type in determine copy all of these load case that you want to include in the envelope, and copy to the below the name. Then you can type in the coefficient. So okay, once you do that, you can select all of this. The you need to select the column envelope and then the coefficient too. So you have to select both of that in order to make the program understand that what coefficient you need to use. And once you select all of this, you click update envelope. Okay, you come back in the program and you check again. So the envelope will be added to your program. Okay, so that is the way we can. Uh, Again, yeah, you want to, after you do that, you will do one checking by show view the envelope. So you will see the program will reload the envelope from the etaps to show you. So you make sure that it has been input correctly. Okay. Um, so now as we finish with define the load combination, let's run the, okay, let's start with the wall design. Now I have, in this simple model, I have 4 walls, so I will try to start with the design of, so to start with the wall design, simply you is to select where is the wall that you want to design by, maybe I will start to design from level 1 to level 5, yeah, 1 to level 5. So I just show the wall from level 1 to level 5. Okay, I will show the wall only. So I select the wall and I will show the wall only. Now you have the wall ready. So the first step to design the wall is you need to assign the wall peer name. There's 2 ways to do it. So one way is using etaps. I think you guys already know. The other way is okay, from the program, and you click to the design, and the wall, you will use the same template with the column. So you just pull out the column design to your design folder, to your calculation folder. So let me open my calculation folder first. For this session, I create the one folder for this. So like wall design. So I will pull this one to the calculation folder. And okay, this one done already, so I could close it. Maybe I save. And I open this template. Okay. You for when you open this template, you can so you can use so you, from the program, you can also define your peer by first you need to tabulate the name of the peer that you want. Let's say I want to design from level 1 to level 5. So I'm just thinking of the name of the wall is the L5, L5, maybe W1, something like that. Okay, and maybe L5, F2, 3, 4, 5. So we have 4 wall I want to design. Then I will open the tabs. Okay, first I will turn on the peer label so that I can be able to see the label. Now it don't have anything yet. Okay, and from the program, you can change this one to wall if you want. Oh, sorry. Oh, yeah, wall up here. And from the program, you go to wall. And now you have two options, either you select wall or spandrel. So so you select the wall name and you select the wall that you want to design. For example, now I select or the wall I want to design, and then I select that, and then I will assign the wall. So you see the program will assign the peer name for that wall. Okay. So I will try to do two walls. So I select this wall as well. So I assign the wall name. So after you assign, you can you run the program. So during the program running, we can I will explain to you another step. So if you remember in the previous column, oh, this done already. Okay. To start with the design, you need to define some of the output. So to define the output, you can go to an empty sheet like this, and then you get the combo list. After getting the combo list, you can pull out the combo that you want to get the output. Copy here, example, and you set the output combo, and you select all of the output you want to get. Okay, after we go back to the analysis table, and um, you can define and after that you can maybe hide. Let me hide this info, as all of these are related to the column, so I just hide it. So once the program finished running already, you can go back to the wall and select all of the wall that you want to get the output, and you will get the false result. Oh, sorry. Okay, this two don't have false results, so that it show error. But the one that have false, it will get the false for you. Yeah. To continue with the design, you copy this name to the table, the design table, and you will copy the name here. Now, if you remember in the previous step, you need to pull out the correct section, the section for the wall. So for this, we just use rectangular section. So we will select this section and assign for the wall. Assign type. Okay. Once you assign type, you will start to you go back to this design tab, and then you click create design sheet. Okay, you create design sheet, and you will select the folder that you want to save all of your design. So I will create a folder calculation, for example, and click open. Okay, if successfully, it will show you the link here. So to go to each link, you can click to select the row, and then you click open a singular sheet. It will open the template, and now you can know what is the variable you want to input. Let's say this wall is so you need to know the dimension of your wall. The program also help you to get the dimension of the wall quite quickly by you go back to the program and go back to the define the analysis sheet, and sorry, you can turn on this, and you can select the wall and go back to the wall tab, and then get the section. Okay, so the program will tell you what is the depth of the wall, and what is the width of the wall. The width means here's the length of the wall and the material, and then also currently what is the wall section is assigned. So you can use this tool to be to define your wall section, and then you come back to the wall section, and maybe you type in. I suggest you to when you design the wall, you turn on each section first to see the graphical interface and you can define some of the variable here. So you input 8 meter for the wall. Sorry, this one is wall height. So it's in this case, I take each floor height, I think about 5 meter, and the height of the wall now you use 8 meter, and 400 will be the width of the wall. And you select and then next you define the cover, and you define how many bar you want to use for this one by just assume some of the you can assume the spacing of the bar. Oh, sorry, this is the rebar along this direction, so I just define only 2. And the rebar diameter, maybe I select 20. I just type in 20. So the rebar along the Z direction, maybe I assume 200 for the spacing. And I can roughly calculate from the length. I can put the formula to roughly calculate the number of rebar by adding, let's say this. I just roughly calculate first, divided by this. So I got about 40 rebar. And rebar meter, I put 20. Corner rebar, I put 20 also. Since this one is the wall, so you try to put the links as less as possible so that the program will not calculate if you put one, the program will not calculate the links. But in this case, along this direction, you also have the horizontal rebar, so you can put the the shear links of 2H10, for example, at 200. Here also have shear link of 2H10 at 200. Okay, and then after that you save. Once you have one section defined already, you can save the session and then come back to the summary table and go back to the design. Then you will you have to click get parameters. Don't click set because if you click set, the program will write whatever in this table into the file. But if you click get parameters, the program will load the parameter from the signal sheet in this table. And you can see that we just type in the, okay, sorry, I would need to unhide this one. Yeah, so we'll no longer use the circular section, so I just hide it. So you can see that the first wall we have key in the section, so it show the update section. The second one we haven't key in, so it still use the template. So you want to apply the same design parameters for the second one, you just copy here. Just copy here, and then you select all of them, and you select set design parameters. Then it will update for you. Okay. Next step, once you define your section already, the next step is because in the previous step you have loaded the force to this table. So you need to transfer the data to the spreadsheet by clicking the transfer data. Okay, and then you delete all the result first, and click save. Then you perform the design. It will check for all of the load case and give you the design, some of the result here. So to look more into each case, you can just click to the row again and open the singular sheet, and you see all the load case, all the load combo has been imported to the program. So this will show you the checking result for each load case. And okay, so you can see right away which one is not satisfied. And if you want to check that load case, for example, you want to check this load case, you go back to the program and open the design, and then you click perform design check. It will import this load to the spreadsheet here, and you will be able to see all of the load checking, and then you can improve your design accordingly. So there's two ways to improve the design. One, you see this one not passing, right? So something the M is not satisfied. Either you can increase the rebar. Uh, you can increase the rebar, and then you check here, and then you save, and then you go back to the summary table, and then you get the parameters. Uh, sorry. Okay, let's check again now. The one that I just opened is this one. Oh yeah, we sorry, is loaded here already. So it loaded the section that we just typed, but for other load case you have to rerun again. Perform design check, so you will be able to see the updated result with the section you just updated. You see it improved already. The other way is if you understand the parameter here already, you don't need to go into each a spreadsheet. Now you just need to modify here. Let's say I modify the rebar here directly, and I can improve the concrete grade as well. Okay, and then I click set parameters, and then perform the design. Okay, then you see it's the result updated right away. Okay, so that is the step to do the wall design. Okay, I'm gonna close this. Okay, in the next section, I will share with you. Yeah, we just continue with this. Let's say I will open the program again. We open the program again. Now you see in the program, we have the section library. We have a section library here. We have 4 sections, right? Now, let's say you have a spreadsheet. Let me pull out one of the spreadsheets I have here. Let's see, I have a spreadsheet to do the calculation for the composite wall, the composite column like this. So this normal spreadsheet we can do for one composite column. I will tell you I will show you how to integrate to this program by just few steps. Okay, now what you do is you open one of the section we have, and then you open your spreadsheet. Okay. Now what you need to do is you need to copy this design summary. You copy this design summary to your spreadsheet, and then you create a copy. Okay, now you have the design summary in your spreadsheet already. Then you go to the main calculation. You also need to copy this output to your spreadsheet as well. Okay. Next, you can close this one already. So that is the tool that you want to do. Okay. Next one, you want to set up. Want to set. Oh, set up. Oh, sorry. You need to do another one more step. Let me open this one. You need to go to the developer, and you go to the VBA. Oh, trouble. Okay. Okay, let me try with other one. I think this one we have password. Maybe Philip, do you remember the password? Okay, maybe I try with other one. Um, so yeah. Okay. Okay, maybe I try with this steel column since we don't have the password. I will repeat the step. Okay, this one already have, so I will not repeat the step. So we copy this design summary to this new spreadsheet. Okay, then you copy this cell to the spreadsheet as well, and also you go to the developer, and this one is the current spreadsheet. You go to the um, so you go to this command, and you have to copy all of this command to the new spreadsheet. So I will copy this. I will insert a module and copy this new command to this spreadsheet. Yeah, I think that's it. Yeah, no more. Okay, that's all you need. And you close. Okay, so now you go back to this design spreadsheet. And what you need to do is you will, in this three variable that you just copy, you have to set the formula. This one, like the UR1, is the maximum of this row. Like you need to get as a maximum of this because the result will be shown in the summary table will be the maximum utilization factor of all of these three columns. Let's say you want to bring out one more utilization factor. You add one more column here. You will add one more row here, and then you set a maximum value for all of these columns. Okay. The next step is you need to, since you just create the, you just copy the design summary from the other spreadsheet to this spreadsheet. So I'm gonna close this one first. You need to do some setup by you need to link this column, this spreadsheet to the calculation spreadsheet by I think this one I showed you before. So the program has the function called cal. So it will have you to link a summary table to the main calculation table by mapping the value address. So you just need to choose um, the index row, and then you will input the address of all the value in the calculation table, and the program will help you to copy each load case of the value of each load case correspondingly, and then get the output back. I think you can watch the previous video to see how the process done. After you mapping the value from this summary table to the main table, I think for this case you have to turn on the use specific cell address, because if you use specific cell address, you can type in the address of the cell. If you don't click this, you have to type in the name of the variable here. So I click this and I will check again. Okay, so this one I check, and then I already see that the program is mapping this is defining this index row already, and then it will it will link to this calculation sheet. Okay, you can check that by select all of the row and click clear. Okay, and click batch run. Oh, it's not linked yet, so there's something wrong. So I will go back to the calculation to see what's wrong. Okay. Go back to the calculation sheet. I will select these sheets again. Okay, and link the calculation. Okay. Okay. Here, let me see this. Oh, okay. You need to go to setting and check what is the Okay, output symbol. Okay, output symbol already correct. And you select all the row again. It's batch one. Okay, you will see that if the program, if the all the definitions successfully done, the program will do the calculation and get the output from this main spreadsheet successfully. Okay. For the column, one more step you need to do is you go to the define setting. Like I go back to this previous spreadsheet I showed you. You go to the define setting, and you see you have to click run VBA macro, and then you have to load the one of the macro that we just copied from the previous spreadsheet. I will do it for this one. I will go back to the define. Here I don't have anything yet. I will select run VBA macro, and I will select the setup KLStructure and click OK and save. One more step, you go to this setting. Okay, let me check first. Go back to this spreadsheet and go to the setting. Yes, so you have to go to the setting and do one more step by clicking include begin and end macro. Okay, that is all the steps you need to set up for a single column spreadsheet. Now you close this spreadsheet and go back to your design calculation folder. I will open the, okay, sorry. So I will create one more folder. I name it column design. Okay, I open the program. I open the design template. Okay, and open the section library. So you see that now we have we just define this one, define this new column type, but we don't have in the section type yet. So what I'm gonna do is I'm gonna pull this one to the library. Okay, I'm gonna delete this here. So it will stay in the library. Now you start with the design by you go back and then pull out this column template into your calculation folder. Oh, sorry, I just okay. And then you close this shell and you open the template. Okay, I'm going to show you again how to do the column design. So you open your cell, your ETABS. You open your ETAB. Maybe you unlock this. I will do it very quick. If you want to see the column design, you can come back to the previous video. Okay, I'm going to do the column design for show all the column first for this floor. So I select all of the column I want to do the design. I type in the name C1 and I open the column and I assign the column group. So to see if the program is activated, I will turn on the unique name and I will be able to see the column group has been assigned for this column. And I run the program. So wait a few minutes for the program to finish running. Okay. After the program finish running, I'm gonna pull out the get combo list, get the combo that I want to do the design with, and then set output combo. Okay. Then come back to the analysis part. I can get the section Okay, here I can get a section, and I also can get the force result. Okay, this previous step. Okay, now we go to the summary sheet. Okay, the summary sheet, previously we only have the sheet for the RC column. Now we just create the steel column, right? I will show you how to create new more another another summary sheet for the steel column. Uh, you can create a new sheet, and the first thing you need to do is you need to copy these three. Sorry, you need to copy some column from the previous spreadsheet, but you must need to include these three column. So you okay? Sorry, something wrong. Okay, I think this one has. Sorry, I changed it here. I copy this. Maybe I just copy the three columns so that you easy to understand, not confused. Okay. What happened? Okay, maybe I copy like this, maybe easier. Okay, good. Okay, so this one is the must. These three columns you need to create. So this one, let's say I will copy steel column here, steel design, because my column is steel, right? Steel design. Okay. Now you go back to the template. You need to do some more setup for this spreadsheet. You go to the template, you open the steel column design. Okay. So you see in this spreadsheet, we just type in some parameters for the design here. We need to do the same thing by write in the parameter you want to do the design for this steel column. But what is the rules to follow? The rule is quite simple. Let's say if you want to bring out, if you want to access these parameters from the singular from the spreadsheet, basically you just need to set the variable for that cell. Like here, I set the variable of let's say I set a variable of the fs here. The hearing steel is fys, right? Once you set the variable, you can just type in the variable here. Okay. And let's say I want to bring out some of the variable. Let's say I want to bring out the section. I will set the name for the steel section. I will type in the section here. Okay, it's quite easy to do so. And for the output, remember previously I showed you to get to have this pre-cell to show the summary of all the utilization factor. We have two summary here, right? And you also need to name the summary. You put the name for the summary like this: check one UR1, check UR2, check UR3, and then you're gonna copy. You're gonna type in the variable here. But remember, for the output, you need to put the star in front of the name. Okay, that's it. That is, you already finished the step to all the step to create a new column section. I will try to make it more beautiful. Okay, so you have the input, right? And then you have the output. Okay, I'm gonna pull out some because this is the steel section, right? So I'm gonna pull out the steel list here. I'm gonna pull out this here. Okay, and create the list for this section so that I can easy to select. I can go to the data. This one is just Excel only, nothing new. you can go to the data, and then you can go to the data validation, and you can set a list, and you select the list of the section. Okay, now you have a pretty good list already. So now you can select the section from this list. Okay. Okay, now we finish the setup. Let's do some design. Okay, so previously we already set up the name for the column, right? So we copy the column's name to the new summary table. Okay. Oh, sorry. What happened? Okay. I'm gonna copy this. Okay. Okay. And now you need to do the same step as previously. You go to the section library, and you select the section that you want to do the design, and you select a site type. Okay, and you will do create the design sheet, and you select the folder that you want to save your design. So I create the folder named calculation, and then I click open. Something wrong. Let me figure out. Okay, may open this. Okay, I think this one. Oh, everything is right. Hmm. Steel columns, everything is right. So what's wrong here? Oh, sorry. That's one more important step that I forgot. So after you create this spreadsheet, because this is the new, so you have to click sheet assign, and then you have to select this row here. Okay, I'm gonna do it again. Okay, you see, you can click sheet assign, and then you have to select the top row, and you click update. Let me try to do it one more time. Okay, so it successfully create a new spreadsheet. Okay, now you will get the parameters. You see all the parameter has been loaded to your summary table. Okay. Now I'm gonna do is I will transfer the data. First I open the single spreadsheet first. You see right now the load com has only 2 cases. And then I'm gonna transfer the data. And then you open the single spreadsheet again. And you see all the load has been transferred. Now you can run the design check. Okay. After you run the design check, you will be able to and you open the single spreadsheet. Let me see. There's something wrong. The program doesn't check. Let me check again. Sorry. Go to the cal and I'm sorry. Oh, it still do the check. Some step is missing here. Let me go back to the summary table. Let me do the okay. Click the design check again. Oh, click the design check again. Oh yes, so it loaded already. So previously, I think there's something wrong with that. Yeah. So now you want to change. The URI is too big, right? So you want to change the section. You can copy the above section and change your section, and set the parameter and do the design again. Oops. What's wrong with this? It's not updated. Okay, let's run one more time. Okay, it's still loaded, but I think the result. Let me. Oh, sorry. I forgot one step. Everybody, anybody know what it is? So since I change this section, after I change this section, I have to select set parameters. Okay, I delete the output and then I run again. Okay, so now it updated with a new one. So if I don't select set parameter, it will not write. It will not write the new method. Okay, that is all the step for adding a new column section from your own spreadsheet. Okay, is easy or difficult? I mean, anyone has any opinion? It's quite easy, I think. Okay. Um, that is the function of the program that I really want everybody to know, because the purpose of this program is I want more engineer to have I want to encourage engineer to engage more into the automation design by creating their own calculation, and the program gives you a pretty good framework how to connect with ETABS to do the automation design. But like, let's say you have new code coming, or new reference of doing design for different structure component, you can create your own spreadsheet and integrate with programs so to improve your design. Okay, that is all I want to share for the column and wall. Then next, I want to share with you a few more modeling techniques for the ETAP by using this program. The first thing I want to show you is, let's say sometimes in our engineering life, we have to deal with quite complicated model from very quite complex structure, steel truss, 3D truss or something like that, and we got the 3D model from architect. The first thing we need to do is we need to turn the architect model into a line model in AutoCAD. And so now we want to quickly import this new model into our programs. So I will show you the few quick steps to do. Of course, you can do by using the CSI software itself, but somehow when you do it, especially when you have an existing model, when you input a new one, it will, I think the program just create a new model and kind of affect your existing model. But if you use the step I want to show you now, you will not disturb your existing model. So to do it, you just turn on your CAD file and open your, let's say here I will play with the SAP model. So I open the SAP model and then I will open the program. Okay, so when you open the program, now you need to interact with SAP, right? So you wanna select SAP and you go to the geometry. In the geometry, it has few function. The name of the function is just show in the name of the button here. So the few things that you want to do, either you can, because you're dealing with CAD. So the unit of the model is a meter, and the unit of the CAD is a millimeter. So first thing you need to do some convert for your model. So you go to the CAD setting, and then you set the drawing scale is 1000, and then you click update. And then now you want to import the frame directly from CAD to ETABS, right? For the CSI. So you click import frame, and after you click import frame, in your CAD program, it show the arrow for this show the symbol for you to select all of the object, and you select all of the object, and then you click right, and then you click and enter, or you click right button of your mouse, and the program will import it directly to your model, like that. That will be I will try to do in the future. This one can on at this moment we can only do frame to more to we can only transfer the frame, but in the future will be more function to transfer the shell and the node from CAD to CSI, so that you can even build your model directly in CAD, and then import it to CSI software. Okay. The next techniques I want to share with you is okay. Let's see. Sometime we I open back the model first. Okay. A lot of the time when we have to deal with facade engineering. So since we have our structure model and the facade model, usually they work separately with us, and they will give us a list of facade load, right? They will name, even they name the load, the point load, named by themselves, and they just give us the chunks of load like this with different load case, and different load value. And some case we got about like let's say 20-30 load case and hundreds of nodes. If we don't have the automatic functions, basically we just try to estimate some of the critical load case and input, because it will take a lot of time to transfer the load from their table to our programs. So this technique will help you to deal with this. Let's say you have the this table. Sorry, I delete one more node. So there will be a Schuma. You can imagine, for example, we have some facade hanging to this node, 1, 2, 3, 4. You have 4 nodes, and each node will have 2 load case, and there's a load value. Okay. First thing you do is you will turn on the unique join name. Okay, sorry, I need to turn off the frame name. Okay, now you have a unique join name, and you have this name in your model. Okay. Now you know that, for example, A1. So you have 4 nodes from the table. Let's say 721, 725, 729, 733. Okay. And now you know that this 721 is corresponding to node A1 from the facade. Okay, you prepare this list first. You prepare this list. Okay. Then next thing you do is you you open the output, and you get the load pattern list. You get a load pattern list in our program. So in our program, luckily we have these 2 load case quite similar to them, but also a little bit different. So and we type in their load case here. Okay. Now you're going to do the setup. You go back to the footing, and you will do assign the load point. So you will select these two columns. Let me think. Let me think. Okay. Okay, we have to do the reverse back. So since you want to transfer the load from here to here, so we have to do the reverse. Sorry. So first you need to type in the source node, and then this is the target node, and similarly you have the source of the load case and the target load. So again, you're gonna do the assign load point. You assign the load point, and then assign load case, or you assign a load case. Okay. Then next you assign the load data. So you select, you want to select all of these node, and you select the load data. Okay. And you save. And now you will click transfer reaction node. Did I do it? Okay. Then, oh, something wrong. 3 transfer. Okay. Sorry, there's something wrong. If let me see, assign node BC, that's correct. Assign load case, that's correct. Assign load data. It's not loaded. Maybe let me try another way. Assign load points, right? Assign load case. Okay, and transfer. Sorry, let me test this again, this function. Okay, let me try by doing the other way. Normally it works. I don't know why this one doesn't work. Let me do another way by adding the changing the node name similarly. So we change the unique name. And if sometimes if the program doesn't work, what you need to do is you will you will change the unique name similarly to between the two program. Oh, this one's A4. Okay. Okay, we have the name similar, and then also list load K, you also change it similarly. Okay. I will try to update my previous function, but previous one normally it will work like that. Okay, so if you have the same node name and the same load function, then you don't need to have two column. Instead, you wanna have only one column, and you select the load point, you select the load case, and you will assign the load data, and let's say transfer reaction node. Yep. So no matter how many reaction node you have, the program will transfer it for you. So with all the load from the load that you input. Okay. So this is the technique to deal with facade load when you have so many load point and so many load case for the facade. So you can get you can import the load from the facade nicely. So this function can also be used to deal with the foundation. So if you have a model like this, and then I will show you the way I create the foundation model and then design the pilot in a very fast manner. Let's say you have this model, you build up to you build the model up to the top of the foundation, and next thing you go to open the safe, okay, and you open the model, the Excel, okay. Then you open the program, and now you go to the footing, go to the sorry, you go to the geometry. Now you want to set set some setup for the foundation. So these are your column location, right? Your column node. Now I want to use this as a reference node, for my safe. Okay. There's two way. Either you can export if you already build the foundation in your EDAPS model, and you can export, you can use the program to export to the safe directly. Or if you have a new model like this, is usually what I do. I will not build the foundation first. I will just build all the superstructure uh, or the superstructure from the top of the column, and then I will start to work on the foundation by first I select all of the column and wall, and from the program I will do import point to Excel, okay. Then I will have the list of the point I just import. Then I open my save, okay, and I will switch the program to save, and I will do again import point to ETAPS. I will select all point. Okay. So the program will sorry. So this one it import to the base, which I don't want. I want the point need to be at the dan the datum surface. I need to check where's my datum surface. So my datum surface at 3 meter. For the variation, usually I will set 1 meter only for the height of the pie. So here I need to change all of the reference point to 1 meter, and then I import to tab again. So by doing this, I have the reference point for my foundation, and then I'm going to build my foundation. Usually we can have a big foundation slab. Then we want to build maybe I will do some quick definition. We do maybe slab, maybe 400. Okay, with some material, euro, concrete. Okay, very quick, something like this. Okay, then we select the foundation. This is for slab, right? For slab, and then I will build another for pie cap. Okay, made for pie cap. For pie cap, for example, pie cap, this one 1500. Define the pie cap. Thick. Okay, and I'm going to draw in my pie cap. Okay, and yeah, so I will draw in my pie cap. Just try to draw it very quick, something like that. This normally what we build the foundation. Okay, for the core wall, maybe we need a very big pie cap. Then next, I'm gonna build the sorry, I'm gonna build a frame section. Okay, I'm gonna build a pie. The section for the pie. Oh, sorry. Okay. Let's say my pie is 1 meter for, I mean, 1.2 meter for each column. Okay, 1.2 meter for each column. Okay, and then I'm going to add the pie for under each column. Pie above, below, this. So you can see from the reference point, we can quickly build our model, right? And below the power, of course, we can view our foundation in the different manner, something like that. Okay. So I came from the reference point. Now I have good model for the foundation. Click save here. Okay. Next I will select all of the node, and I will not assign anything yet. Restrain set it to none. Okay, I'm gonna save it. Okay, now I will create the table for the pie. You can can create your template, but let's say I start with the borehole one, and the pie diameter. The pie diameter, I say 1/200, and you can pick the pie area. So the pie area is times with this, divided by 4, and you can assume the pie stress. Let's say 8.5, or this one you have to check with the code, okay? And from pie stress, you can estimate the working load. This and this divided by 1,000. Then you assume the deflection, the settlement, let's say 0.1, and from this you can calculate the now. Okay, this one you try to put the name, right? Now you go back to the define, you assign the point, and this one you put a point name. You can put your point name. Let's say I set the it equal to p with this diameter. So every time of this one, I also set the borehole, right? Because borehole is different. You can also have a different pie name. So something like this. So I have a pie name. So every time I change this pie borehole and diameter, I have different pie name, right? And this one is deflection. Then I will show how I will look at the define, and I go down and try to find the okay, the spring stiffness. I will bring this tree to the file, to the model. Sorry, I will need to bring the name spring first. Where's the spring? Point spring. Okay, spring. Assign here. So this one is the name index, and then the spring name I just assign similar to the point name. Now I have a spring KS, which equal to this working load divided by the friction. And if I want to divide the horizontal spring, and this maybe divided by 10, this divided by 10. Okay, I save. So so you have something like this to start with your model for the foundation. And next thing you need to do is if the your load is quite the same, you can select all of these pi and you go to the footing and then you assign the point group. Okay, after you do this, you can see the program will show you the, I'm sorry, um the point restraint, sorry. I select the point again and select all the point. Oh, sorry, why I cannot select? Right? Oop, there's something wrong. Because previously we draw it beyond the dentum, so we cannot select. So you have to move this to the dentum by in move 2 meter. So okay, go back to this pi, and then you say now you can select, and then you remove all of the spring, and now you assign the pi name accordingly. Okay, you assign a group. Okay. Sorry. Assign the point group. Okay, you can see that after we assign the point group, in the file name, in the pi name is showing that group already. And the next thing you want to do is you will sorry. Now you have a spring name already, and you go back to the modeling, and in your model now you don't have any point spring data yet, but you have just defined some spring parameter here. So you set, you're gonna choose point spring, and then you set a point spring, and you can see the point spring is imported to the model. Okay, and next step is I want to turn on the spring view so that you can see the spring. Now no spring has been assigned yet. Next step you do is go to the footing, and then you set the point. You set the point property. Okay, and after you set the point property, you can see all the spring with the point with your point group, and then spring has been assigned accordingly. Um, if you want to have more type of pi, let's say 1000 for example, and then you have more spring, right? You go back and you need to create more spring, set the spring property. You can see the more spring is imported to your model. And let's say you want to assign all of this pi with this pi group. You go back to the footing, and then you assign the point group, and you select all of this, and you select set point property, and then you refresh, and now you can see all of the spring point spring in the um, in your load is being imported accordingly. Okay, then next one is you need to because this safe model is a new model, right? So you need to import all of the load pattern from your EDAP model to this safe model by using the previous step I showed you. You go back to the EDAPs. You go back to the EDAPs, and you go to output, and then you go get the load pattern list. Okay, I'm gonna do it very fast. Because I already showed it before. So now you switch to your safe, and you choose all of the list, the load list, and then you click update load pattern, then the load pattern, it will be updated to your shape model already, and you click save. Okay, now you go back to your EDAP model, and then you're going to run your program. Okay, and then here you need to do some setup. You go back to the save model, and you select all of the node of the pi load. Sorry. You select the oh, sorry. Previously we have this node name already, right? And now you copy this node name to this sheet, and then you do the same setup that you do previously with your putting. So you're going to assign a load point, okay, and you're going to assign a load case. Now all the load case is assigned already because the same. Then you go to your EDAP model. Once the program finished running, you choose any empty cell, and then you select get reaction force. Oh, have to switch to EDAP, and you select get reaction force. I should click save first. Sometimes the it takes too much long time to run, and it just crash. Now that thing is still running. Come on. Let's wait for 5 more seconds, and if not running, I will restart. 1, 2, 3, 4, 5. Okay, I'm gonna restart. Sorry. Restart the program. Okay, I'm going to do it one more time. So I suggest every time before you run the program, please click save first, because sometimes the memory is stuck in the program and you cannot proceed. So you set the load point, you can set the load case accordingly, right? And you save, and from ETAPS, you get the reaction force. Okay, you can see that previously I showed you the load facade table, right? Now from that we can also get this table from all the reaction of each column load from ETAPS. Now you go back to your safe, and right now the safe don't have any load yet for sure because we just created. And now you just need to switch to the safe and assign all the load data. So you assign all the load data for this table, and after that you save and you transfer the force. And now you open this, and then you will be able to see that all the load from the EDAP is transferred to the safe already. And you can run the safe analysis. The spring is assigned already, right? And now go back. I want to maybe a few more minutes. I will show you how to use this foundation result and how to improve the foundation design. So after you run, then each part you will have your load, right? And now you want to bring your load into your table. Okay, this one we don't have the load combination first. So let me unlock and then import some of the load combination from EDAP's model. Similar to the previous step, you go back to the output and switch back to the ETABS model, and you go into view the combo. Okay, and after you view the combo, you can also view the envelope. So once you have this table, you go back to your safe, switch back to safe, and you select all of the load combo, and you update the load combo, and after that you go to the load envelope, and then you also maybe I select too much, update the envelope. So once you do that, you have the load combination, and the envelope has been in your safe model already. Okay, I think BA1, okay, here. And after that, you run the safe again and go back to your Pi summary design. Now you want to bring out some of the load combination. So quite easy, you go back to the load combo, and you want to see, sorry, the load combo, you want to see the load from the Pi for some of the load combo. So either you can copy the load combo name here. In case I want to see the envelope load, so I just put the name of the envelope that I want to see here. Okay, I just put it here. Okay, and remember, this one is a group of pi. This is a group of pi. So after you run, right, then after the program running, you can go to the footing, and you can get the maximum reaction. Okay. So, and then you can compare with the capacity from geo team. So if it's not satisfied, you can increase, you can create the more pi. And uh, what I usually do is I can compare the working load. I have one more load case for the working load, and then I compare with my assumed working load. And if it's not the result is too different, I will adjust the I will try to adjust the working load until it match. But every time you do it and you adjust the working load, you need to adjust the stiffness, right? So it's the program allow you to very easy to do that by every time you adjust the number here, you can just go back to the modeling, and then you set the bring prop. Then I will take it, for example, now you want to adjust the spring. Let's say you want to increase the stress a little bit, right? Previously, the stiffness was for this it was 6 right? Now you after you assume the stiffness, you set the spring property. Oh, sorry. Okay, set the spring property. You have to select the spring, and you go back to your spring model, and you will see the spring has been updated, and you rerun the program with the new spring updated, and you delete the load, and okay, and right away you can see the after the program finished running, and okay, right away you go to the footing, and then you can get the maximum reaction. Okay, it's quite fast doing that way, especially consider you have so many pi or so many pi need to do at the same time. It's quite take sometimes it quite quite long for us to process our case. Okay, next. Sometimes we really want to interpret the result and communicate with Geo, for example. Uh, the program has a function called data interpretation. So now you select all of your pi, okay, and you go to the footing, and you get the point list. Oh, you have to select, sorry, you have to select 2 cell and, oh, sorry. I have select 2 cell and then you get the point list. Okay. You go to define first, you get the point first. And here you're going to get the some coordinate, x coordinate, y coordinate, index, oh, sorry. And get a point. And now you're gonna bring, let's say, DA1, 1. Okay. Then you go back to the footing and select all the point, and you're going to get the point property and the spring. It will show you all the spring and the point. Okay. And also you can do the same thing by getting the maximum reaction. Okay. Now we want to interpret this result into the foundation plan to maybe communicate or making more decision. So you open, let's say you have the foundation layout, and first you determine, you just draw a circle to the originate point, and you know this point, you don't roughly this point where this point is in the model already. Okay. Then of course, this is, I assume this is your piling plan. You should have your piling drawing already. So now you want to interpret some of the result from your load data. So for example, I will create one layer. I call it spring, and then I create another layer, call it DA11 is the load case. Maybe make the color nice a little bit. Okay. Okay, and maybe close this, and then change this one to spring. Okay, and you go back to the data geometry, and you go to the CAD setting. You set the drawing scale first, and then you go to get, and you click get, and then you select the circle here to define the ordinate, and then you click update. And next you go to the text setting, and then you will select the coordinate range. Okay, and you can select some like text size, define some text size, this decimal behind the text. Click update. Click update. Okay. Then from here, let's say you want to bring out the spring. We select all the spring, and we select plot result. Oh, the text is too big. Let's do the text setting. You can maybe bring the text back to 200, and you plot result. Oh, sorry, we change a little bit more. I think 500 would be good. Okay, so you can see that it will plot your spring result. Okay, if you want to do some more things, for example, you will select the different coordinate. Okay, I will delete the result here. Okay, now I want to bring out the DA11 to see where is how it goes, and I'm gonna plot result. Okay, so it show me the force corresponding to each pi, so you can make a decision by seeing if the force is quite close or not, or transfer this data to 0 for their input for their practice. Okay. One thing I want to to remind you, between when you transfer the load from your EDAPS model to safe model, be very careful. Okay, because sometimes, especially when we do the EDAPS model, the way that we transfer the load is we transfer only the point load. Okay, we only transfer the point load. That's why if you in your EDAPS model, if you set up the wall mesh automatically, it will have a mesh the wall, it will define the constraint with the of the wall edge with the at the basement, so that all of the point here will assign the constraint, so that the load is assigned along the wall. So normally I will ignore that by using the manual mesh. But I will assign the point load to wall manually. I think in this model it has these errors. I will show you how to check this error if your model sometimes wrong. So you go to your ETAPS program. ETAP program. You come back to your ETAP. Let's pull out the load case. Right now I have I have the load SLS. Let's see. Load case. Where's SLS? Okay, here. I just pull out this load case. I pull out this load case. Okay, maybe I create a new file for this. Okay, and you go back to your ETAS model, and from the program you go to output, and you get the get base reaction. You click get base reaction. Okay, the program will tell you what's the base reaction for the model. So this is ETAPS. Okay, and you do the same for safe, and you go switch program to safe, and then you also get base reaction. If you see the base reaction, if it's like this, if it's a little bit more than the ETAPS, it means that the result is quite correct, because your safe model is the load from ETAPS and also the weight and some load from your foundation. So it have to be more than the weight for the base reaction from ETAP itself. But sometimes I show you an example. If we select this model from ETAPS. Oh yeah, I just want to warn you, like, this is the way to check. It will take a lot of time but I think some of you do the modeling long enough know what I'm talking about. So if you select the wall mesh, and and then you assign when you assign the mesh, you click this adding the restraint for H. Okay, if you click this, then you will have a lot of the load not transfer to the point. Instead of, you have a lot of the point along the wall, the base of the wall, and then the load is not all of the load not transfer to not all of the load transfer to the point. That's all. That's all I want to share with you about these programs. I hope that this will be quite helpful for your work. This session, I think, will be the final section. Maybe everyone really know that this is today is my last day at Manhattan. Any further question about the program, you still can contact me. I want to use this opportunity to thanks everyone for your support during the time that I work here. That's all. So you have any question for this session, or yeah, that's all from me. Thanks.
Thanks a lot,
Any
Ken.
question?
Thanks.
Okay.
I think I just want to have a few words here. Now, this program is actually, there's a huge effort. I think it take don't know how many days or how many months or even few years. Actually, I was trying to learn a little bit on this, but take a lot of my time. So in the end, nothing much developed from my end yet. All what I want to say is this is a huge effort. Thing like plotting or importing loading from different program, ETAP to SAFE or to SAP 2000. Previously, when I tried to do it in quite manual way, it takes only the load combination itself. It already took me a few months already. But this tool is definitely save tons of hour. For me, I think it is very useful. don't know what is the rest experience. But anyway, thanks a lot, Ken, on this.
Okay.
I
Okay.
think
You're
the
welcome.
rest will need to have some time to. I think may need to review the video and may try out, and then along the way we'll among our team we discuss and
Sure.
learn more
Sure.
from you. Yeah.
Sure. Okay.
Maybe
Anyone
we
else
go for
has
lunch
any more
already.
question? Sure. Yeah. Sorry, take you quite longer a little bit. Okay. Thank you. Thanks everyone. Yeah, I close.
Yep.